Hello everyone, I am Praveen and this video is about the Task-6 for Data Science Intern of the Sparks Foundation GRIP program. So the task is to perform prediction using the decision tree algorithm, and the dataset we are provided with is the IRIS dataset. So let's proceed. So the first thing I did is to import all the necessary dependencies and the libraries. Pandas for the data manipulation I still learned from splitting the data, and of course for the model, the decision tree model, NumPy for numerical functions, and Seaborn and Matplot for the visualization purposes. And then this is how I loaded the IRIS dataset into the Jupyter notebook. And then it is always a good practice to, before performing any functions on the data, to do some data analysis. So as you can see, using the iris.head and iris.tail, we can get a brief overview of how the data looks, and then using iris.shape, I'm able to know how many rows and columns are there in this dataset. And then with iris.info, we can see if there are any null values in the data, so we can know if we need to do some cleaning of the data, and then also the data types of the features. And then once I'm done with that, I went ahead and some data visualization. This is a pair plot, which is also of course a scatter plot of pairs of features. So as you can see, this plotted scatter plots for every a pair of every two features in the data, and from this plot it can be clearly visible that petal width is the most reliable feature to differentiate between the flowers, and this can be seen from the fact that whenever petal width is there in one of these features, the instances are being very distinct and separate, as opposed to something like this where sepal length and sepal width are there. You can't really differentiate between two different groups. Yeah. And then it is time to prepare the data for the decision tree algorithm. The first thing I did is to separate the target variable from the rest of the features. So H is the data set of the features, as you can see here, and then Y is the target variable, which is species. And then before performing the decision tree algorithm, finally once I did the correlation matrix and I've plotted it as a heat map, this gives some valuable information, like for instance, as you can see, petal length and petal width have the highest positive correlation. You shouldn't consider the one in this diagonal because they are one and the same, as you can see, sepal width and sepal width. So other than that, petal length and petal width has the highest positive correlation, and this is minus 0.42, which is the highest negative correlation, which is between petal length and sepal width. Now that it is finished, I went ahead and trained the decision tree model, and then I fitted it with treeclassFair.fit using xtrain and pytrain. And then I went and did the predictions, and as you can see, this is the actual target variable feature from the test set, and these are the predictions done by our model, and as you can see, it is always correct. The test set has I believe is completely accurate. And then I went ahead and did some visualization to the decision tree, and as we have predicted earlier from the scatter plot, the petal width is after all the most reliable feature. That is why it is the first node, and then it is petal length, and then comes sepal length and sepal width for the classification. And then finally I went and did the model evaluation using the transfusion matrix and classification report, and I've plotted it as a heat map. And as you can see, the model is performing very well, and the only error that has happened is possibly due to some kind of outlier. And also the F1 score is easily above 90%, so this proves that the model is fit and is predicting well. Now any new data can be given to this model and the prediction will go well. Thank you.